Welcome in React section संस्थान महात्मा गांधी विद्यालय and Junior College, Saurus. This is Kamleser's online lecture on chapter number 6, Redox Reaction of 11th standard. This chapter is important for 12th standard, chapter Electrochemistry. Let us see the term redox. Redox is abbreviation used for two terms, oxidation and reduction. Redox process also observed in the processes such as respiration, rusting, combustion of fuel. Now see some classical ideas of redox reaction. First term, oxidation. Let us see some definitions of oxidation. Number one, oxidation is combination of an element or a substance with oxygen. Example, carbon when combined with oxygen produce carbon dioxide. Second example, magnesium combined with oxygen to form its magnesium oxide. Second definition, removal of hydrogen is also oxidation. Example, twice H2S plus O2 gives twice H plus twice H2. Third definition, combination with electronegative element is also oxidation. Example, magnesium plus F2 produce magnesium chloride. In this example, electronegative element fluorine is combined with magnesium. Fourth definition, removal of electropositive element is also oxidation. Example, Hg2Cl2 gives HgCl2 plus Hg. In this example, electropositive element Hg is removed. Now let us see second term, reduction, and its definitions. Number one, reduction is removal of oxygen. Example, twice Fe2O3 plus thrice C produce 4Fe plus 5CO2. Second example, twice HgO gives twice Hg plus O2. Second definition, removal of electronegative element is also reduction. Example, twice FeCl3 plus H2 produce twice FeCl2 plus twice HCl. Third definition, addition of hydrogen is also reduction. Example, when ethene is reduced by H2 produce ethane. Now see some other terms in this chapter. First, oxidants or oxidizing agent. A reagent or substance which itself undergoes reduction and causes oxidation of another species is called oxidants or oxidizing agents. Next, reductant or reducing agent. A reagent or substance which itself undergoes oxidation bring about reduction of another substance is called as reductant or reducing agent. Redox reaction can also explain in terms of electron transfer. Redox reaction can be described as electron transfer by the following example. First example, Mg plus O2 produce Mg2 plus O2 minus. Second example, Mg plus F2 produce Mg2 plus F2 minus. In first example C, according to development of charges on the species produced, the reactions can be written as, see the reaction on the screen, Mg plus O2 produce Mg2 plus O2 minus. In this example, the arrowhead which joins Mg to Mg2 plus, there is loss of 2 electrons, and the arrowhead which joins O2 to O2 minus, there is gain of 2 electrons. In this reaction, Mg atom loses electrons to form Mg2 plus, and oxygen accept electrons to form O2 minus. Each above steps can be represented by half reactions as below. Mg produce Mg2 plus 2 electrons. Oxygen accept 2 electrons to form O2 minus. Sum of these half reactions is a redox reaction. Now, on this you can solve few questions. Question number 1. Write half reactions from the following overall reaction. Mg plus F2 produce Mg2 plus F2 minus. Second question. Write overall reactions from following half reactions. Fe produce Fe2 plus 2 electrons. Cu2 plus 2 electrons produce Cu. Now let us see few more terms in this chapter on the basis of electron transfer. First, oxidation. The reaction which involves loss of electron is called as oxidation. Next, oxidants or oxidizing agent. The substance or species which accept electrons are called as oxidizing agents. Next, reduction. The reaction which involves gain of electron is called as reduction. Next, reductants or reducing agents. The substance or species which donate electrons are called as reducing agents. One reaction, displacement reaction. Definition. The reactions in which ion in a compound is replaced by an ion of another element is called as displacement reaction. Example, Zn plus CuSO4 produce ZnSO4 plus Cu. Students, solve one question on this. Complete the following displacement reactions. Write the reactions given below the question. Now see one more term in this chapter, oxidation number. There are some reactions involve covalent bonds. Twice H2 plus O2 produce twice H2. One more example. H2 plus Cl2 produce twice HCl. The products of both these reactions are polar covalent molecules. There is an electron shift rather than complete electron transfer. Electron pair in covalent bond is assumed to belong to more electronegative element. Now see the definition of oxidation number. Oxidation number of an element in a compound is defined as the number of electrical charges it carries. Students, there are some rules for determination of oxidation number. See the rules to assign oxidation number. Number 1. The oxidation number of each atom of an element in free state is 0. Example, H2, O2, Cl2, O3, S8, P4, Ca, etc. Number 2. The oxidation number of an element in a monoatomic ion is equal to its charge. Alkali metals have oxidation number +1. Example, NaCl. Alkaline earth metals have +2 oxidation number. Example, CaCO3, MgCl2. Aluminum have +3 oxidation number. Third rule, the oxidation number of oxygen is usually -2, except in peroxide or peroxide ion, it is -1, and in superoxide ion, it is -1/2. Example, in CO, it is -2. In hydrogen peroxide, the oxidation number of oxygen is -1. In O2, it is -1. In KO2, it is -1/2. In OF2, it is +2. Fourth rule, the oxidation number of hydrogen atom is either +1 or -1. When hydrogen atom is bonded to non-metal, its oxidation number is +1. When it is bonded to metals, its oxidation number is -1. Example, OH minus ion, the oxidation number of hydrogen is -1. In water, the oxidation number of hydrogen is +1. In lithium hydride, it is -1. In calcium hydride, it is -1. Fifth rule, the oxidation number of fluorine is -1. in its all compound. The other halogens, chlorine, bromine and iodine, the oxidation number is -1 in their halide compounds. But in compounds in which chlorine, bromine and iodine are bonded to oxygen, it is +1. Example, in HF, the oxidation number is -1 of F. In KBr, the oxidation number of bromine is -1. In ClOCl, the oxidation number of Cl is +1. In HOCl, the oxidation number is +1. Sixth rule, the algebraic sum of oxidation numbers of all the atoms in a neutral molecule is 0. Seventh rule, the algebraic sum of oxidation number of all the atoms in a polyatomic ion is equal to net charge of the ion. Eighth rule, when two or more atoms of an element are present in a molecule or ion, oxidation number of the atom of that element will be average oxidation number of all the atoms of that element in that molecule. Now see problem over this. Deduce the oxidation number of sulfur in the following specimens. First example SO2, second example SO4 2-. See the solution of first example. SO2 is a neutral molecule. Therefore, sum of oxidation number of all the atoms of SO2 is equal to 0, which is equal to oxidation number of sulfur plus 2 into oxidation number of oxygen. Therefore, 0 is equal to oxidation number of sulfur plus 2 into -2. Therefore, oxidation number of sulfur in SO2 is equal to 0 minus 2 into -2, which is equal to 0 minus -4, which is equal to +4. Therefore, the oxidation number of sulfur in SO2 is +4. Likewise, you can learn the second example on the screen. Now let us learn one concept in this chapter, stock notation. Oxidation number represents the oxidation state of an atom and is also denoted by Roman numeral in the parenthesis after the chemical symbol in the molecule formula. The representation is called as stock notation in the name of German scientist Alfred Stock. Example, Au1 plus Cl minus can be represented as Au in parenthesis first Cl. Au3 plus Cl3 minus can be represented as Au third in parenthesis Cl3. Sn4 plus Cl3 minus 1 can be represented as Sn fourth in the parenthesis Cl4. Now let us learn some redox concept in terms of oxidation number. First, oxidation. An increase in oxidation number of an element in given substance is called oxidation. Next, reduction. And decrease in oxidation number of an element in given substance is called as reduction. Next, oxidizing agent. A substance which increases oxidation number of an element in a given substance and itself undergoes decrease in oxidation number is called oxidizing agent. Next, reducing agent. A substance which lowers oxidation number of an element in a given substance and itself undergoes increase in oxidation number is called reducing agent. Now let us learn one problem on this. Assign oxidation number to each element in the following compounds or ions. There are few examples on the screen. From those, we are going to learn first example, KMnO4. Oxidation number of K is +1. Oxidation number of oxygen is -2. Sum of oxidation number of all the atoms is 0. Therefore, +1 plus x plus 4 into -2 is equal to 0. +1 plus x minus 8 is equal to 0. X minus 7 is equal to 0. Therefore, x is equal to 7. Therefore, oxidation number of Mn is +7 in KMnO4. Let us learn one more problem on this. Assign oxidation number of atoms other than oxygen and hydrogen in the following species. There are few examples on the screen, from which only one example we are going to learn. First example, SO3 2 minus. Oxidation number of sulfur plus 3 into minus 2 is equal to minus 2. The charge on the species. Oxidation number of sulfur minus 6 is equal to minus 2. Therefore, oxidation number of sulfur is equal to minus 2 plus 6. Therefore, oxidation number of sulfur is equal to plus 4. There is homework for you. Solve remaining problems as above using the rules to assign oxidation number. Write the problem on the screen properly. Identify whether the following reactions are redox or not. State oxidants and reductants therein. Write the equation on the screen. There are some rules for balancing redox reactions. There are two methods to balance redox reaction. First method, oxidation number method. Step 1. Write unbalanced equation. Identify the atoms which undergo change in oxidation number and by how much. Draw arrows to denote change in oxidation number. Step 2. Show net increase in oxidation number per atom. Also show net decrease in oxidation number per atom. Determine the factors which will make the total increase and decrease equal. Insert the coefficient into the equation. Step 3. Balance oxygen atoms by adding same number of H2O to the side containing less oxygen. Balance H atoms by adding same number of H plus ions to the side having less hydrogen atoms. Step 4. If the reaction occurs in basic medium, then add OH minus equal to number of H plus ions added in step 3 on both sides of equation. Combine the H plus and OH minus on the same side and write as H2. Step 5. Check the equation with respect to number of atoms of each element and the charges. The reaction is balanced now. Note: for acidic medium, step 4 is ignored. Let us see one problem over this. Using oxidation number method, write the net ionic equation for the reaction of potassium permanganate KN4 with ferrous sulfate, formula FeSO4. The equation is MnO4 minus plus Fe2 plus gives Mn2 plus Fe3 plus. See the solution of this problem. Step 1. Write the skeletal ionic equation as MnO4 minus plus Fe2 plus gives Mn2 plus Fe3 plus. Step 2. Assign oxidation number to Mn and Fe and calculate the increase and decrease in oxidation number and make them equal. See on the screen. The oxidation number are calculated and written below the symbol of the elements. The oxidation number of Mn is plus 7. The oxidation number of oxygen is minus 2. The oxidation number of Fe is plus 2. The oxidation number of Mn is plus 2 on right hand side. The oxidation number of Fe is plus 3 on right hand side. Increase in oxidation number. In the half reaction, Fe2 plus gives Fe3 plus. The increase per atom is equal to 1. Decrease in oxidation number. See the half reaction, Mn plus 7 gives Mn plus 2. Decrease per atom is equal to 5. To make the net decrease and increase equal, we must take 5 Fe2 plus. So the reaction becomes MnO4 minus plus 5 Fe2 plus gives Mn2 plus 5 Fe3 plus. In step 3, balance the oxygen atoms by adding 4H2 to the right hand side. So the reaction becomes MnO4 minus plus 5 Fe2 plus gives Mn2 plus 5 Fe3 plus 4H2. In step 4, The medium is acidic. To make the charges and the hydrogen atom on the two sides equal, add 8H plus on left hand side. MnO4 minus plus 5H2 plus 8H plus gives Mn2 plus 5H3 plus 4H2O. In step 5, check the two sides for balance of charges and atoms. The net ionic equation obtained in step 4 is the balanced equation. See the equation on the screen. Now there is one homework for you. Balance the following reaction by oxidation number method. CO plus NH3 gives Cu plus N2 plus H2O. There is one more method for balancing reaction. This method is called as ion electron method, which is also called as half reaction method. In this method, two half equations are balanced separately and then added together to give balanced equation. There are following steps involved in this method. Step first, write unbalanced equation for the redox reaction. Assign oxidation number to all the atoms in the reactant and products. Divide the equation in two half equations. One involve increase in oxidation number and another involve decrease in oxidation number. Write the two half reactions separately. In step second, balance the atoms except oxygen and hydrogen in each half equation. Then balance oxygen atoms by adding H2 to the side with less oxygen atoms. In step third, balance the hydrogen atoms by adding H plus ions to the side with less hydrogen atoms. In step 4, balance the charges by adding electrons to the oxidation half reaction and to the reduction half reaction. In step 5, multiply half equations by suitable factor to equalize number of electrons in both half equations. Add two half reactions and cancel the number of electrons on the both sides. Step 6. If equation occurs in basic medium, then add OH minus equal to H plus ions on both sides. Then combine H plus and OH minus to give H2O molecules. In step 7, check that equation balance in both atoms and charges. Let us learn one problem over this by solving half reaction method. Balance the following unbalanced equations in acidic medium by ion electron method or half reaction method. See the reaction on the screen. Mn2 plus ClO3 minus gives MnO2 plus ClO2. The arrowhead which joins Mn on the reaction, there is loss of 2 electrons. The arrowhead which joins oxygens, there is gain of 1 electron. In step first, write unbalanced equation for redox reaction. Assign oxidation number to all the atoms in reactant and product. Then divide the equation into half equations. So the oxidation half equation becomes Mn2 plus gives MnO2. Reduction half reaction is ClO3 minus gives ClO2. In step second, balance half equation for oxygen atom by adding H2 to the side with less oxygen atom. Add 2 H2O to left hand side and 1 H2 to right hand side. So the reaction, half reactions becomes Mn2 plus 2 H2 gives MnO2. ClO3 minus gives ClO2 plus H2. In step third, balance hydrogen atoms by adding H plus ions to the side with less H. Hence, 4 H plus ions to the right hand side and 2 H plus ions to the left hand side should be added. Mn2 plus 2 H2 gives MnO2 plus 4H plus. ClO3 minus 2H plus gives ClO2 plus 1H2 molecule. In step 4, now add 2 electrons to the right hand side and add 1 electron to the left hand side to balance the charges. So the two half reactions becomes Mn2 plus 2H2 gives MnO2 plus 4H plus 2 electrons. ClO3 minus 2H plus electron gives ClO2 plus 1H2 molecule. In step 5, multiply reduction half reaction by 2 to equalize number of electrons. into half equations. So the equation becomes 2ClO3 minus plus 4H plus 2 electrons gives 2ClO2 plus 2H2. Equation 1 plus equation 2 gives net reaction. Cancel the same number of electrons, ions and other molecules on opposite sides. So the equation becomes Mn2 plus 2ClO3 minus gives MnO2 plus 2ClO2. This is the balance reaction in terms of number of atoms and charges. There is one homework for you. Balance the following unbalanced equation by an electron method or half reaction method. Write the reaction properly. H2O2 plus ClO4 minus gives ClO2 plus O2. Redox reaction and electrode potential. See the diagram on the screen. This is the Daniell cell in which there are two containers. In one container, zinc electrode is dipped in zinc salt solution. In another container, copper electrode is dipped in copper salt solution. These electrodes are external joined by wire through switch and voltmeter. The solutions are connected by salt bridge. We will explain this in the next. In Daniell cell, there are two containers. In one container, zinc rod is dipped in zinc salt solution, and in another container, copper rod is dipped in copper salt solution. Second, the zinc and copper rods are connected by electric wire through switch and voltmeter. Third point, the solutions in two containers are connected by salt bridge. Salt bridge means U-shaped glass tube containing a gel of KCl or NH4NO3 ammonium nitrate in agar-agar solution. Next, when switch is on, electrical circuit is complete indicated by deflection in voltmeter. Fifth point, the circuit has two parts. One is electrical wire which flows electrons and other is solutions in which ions are transferred. Sixth point, when circuit is complete, zinc atoms spontaneously lose electrons which transfer through wire to copper rod where these electrons are accepted by us. Here, zinc plate act as anode and copper plate act as cathode, which is positive electron. This is simple electrochemical cell called Daniell cell in which electricity is generated by redox reaction. 9 point, an electrical potential is established at two electrodes of electrochemical cell which is called as electrode potential. Now let us learn what is standard electrode potential. When concentration of each species taking part in electrode reaction is unity and temperature is 298 Kelvin, observed electrode potential is called as standard electrode potential, which is denoted by symbol E0. Standard electrode potential of hydrogen is 0.00. Standard hydrogen electrode is used as reference electrode or for determination of standard electrode potential values of various redox couples. Significance of standard electrode potential values are as below. First, electrode reaction considered for the electrode potential is reduction reaction. A negative standard electrode potential means redox couple is strong reducing agent than H plus H. Next, large negative value of standard electrode potential, redox couple is stronger reducing agent. Next, more positive value of E0 means redox couple is stronger oxidizing agent. Alkali metals have high value of E0 which means they are strong reducing agent. Next, alkali metals have a tendency to lose electrons and form cations. Fluorine has high positive value of E0 and thus has great tendency to gain electrons and forms anions. 8th point, if sum of E0 values is positive, the reaction is spontaneous. If sum of E0 value is negative, the reaction is non-spontaneous.